that you're trying to rewrite the, let me rewrite this out first. Remember, it's going to be log base b. It's log base b of y is x, so b to the x is y. That's where all this stuff comes from. And what we're going to do here is we're going to work towards these properties of logarithms that allow you to simplify. And that's kind of the big thing of working with logs. For example, 32, 33, and 34. What happens is when you have the log base b of the same b there, whatever, those two are the same, the answer has to be 1. Okay? So for 32, log base 1/4 of 1/4 means 1/4 to what power is 1/4? Well, that's 1/4 to the first power. So that means that the answer here has to be 1. Those are the kind of questions you ask yourself as you work with logarithms. Okay? As you get into the next one, it says log. We didn't do this one yet. I'm going to come back to that in a second. But log base 4 to a half. So 4 to what power is a half? 4 to the negative 0.5?
No.
4 to what power is going to give you a half? That's kind of what you're asking yourself here. The negative. Wait, I'm sorry. Yeah, negative 1/2.
Yeah.
I had to think about it. Another way of thinking about it, is to go the other direction. Start with what this is. 1/2 to what power is going to equal 4. In that case, you know you'd have to flip the fraction and do something. Okay. Now, the other thing that we come up with is this property. This is the new one for today. We'll start with this right away. When you have log base b of b to the x, basically what I'm saying here, logarithms have a base, and anything written to an exponent also has a base. Okay? So in this case here, there are two bases. Those bases are the same. If those bases are the same, those two bases are the same, your answer is the exponent. So the example, like in 33, where it was log base 4 of 4 to the negative 0.38, log has a base. This exponent here also has a base. These bases are the same, which means that your answer is the exponent. Okay. That's one of the nice properties about logarithms that allow things to simplify themselves through. Sir?
What if they're different bases?
You'd have to change the base of the secondary one to make it that one, and that's kind of how, this is kind of where we start going with inverses and solving equations and all that other stuff. So we're building into that stuff today. Okay. Same thing, and that's what 35 is. 35 was log base 25, I think, of 5. So it's log base 1/5?
Yes.
Okay. So that means you want to rewrite 25 as a base 1/5. So if you're going to rewrite base log of this part as 25 as a base of 1/5, well, that means you'd have to have 1/5 raised to what power equal 25? Well, obviously you'd have to flip the fraction, which means you have to have a negative exponent. -2, very good. So this is log base 1/5 of 1/5 to the -2, which gives you then an answer of -2. Remember, when these two bases are the same, the answer is the exponent. Okay, that's the trick to these things. You're going to work to getting the same base so the exponents drop. Okay, that's how some of these properties of exponents are going to work themselves through. Okay. Also, one of the things that we've done is that you have inverse properties. This is going to be, I'm adding to the notes stuff here. We're just going to add a couple problems to what we did last night, and using quick simplifying and finding a couple of inverses. I'm going to introduce you to Mr. Natural Log. No, we're not in that neighborhood. I don't have my sweater vest on for my cardigan. Please, that's all you wrote it. These two guys are inverses of one another. And remember how you guys found inverses earlier? Now you need a calculator. It would be helpful. Remember how you found inverses before? Yes, sir. That's how you can rewrite it, but what I want you to think of is how would you find the inverse of, how would you verify two things are inverses? You replace one with the other. To find an inverse, you replace x and y and resolve for y. To verify that they're inverses, you take f of g of x, and what should that equal if it's an inverse? Write this down. You're not going to just remember this. Write this down and ask somebody. You're a sophomore in high school. What should this equal? No, get a pencil and paper. How do you come to class with nothing? Should equal x. You do the same thing going the other direction. Should also equal x. So what happens here is when you have stuff written out as log base b of x, its inverse is b to the x. Okay? Those two are inverses, and this is how this works. And these are the properties like you will use on what was it, number 33, 35. There's a couple of these properties that drop real quick. For example, when you did this problem, you'd start with the g of x equation, and then you would surround it with the f equation by replacing this with the x. So this becomes log base b of b to the x. So notice how you have two bases, a log base and an exponent base, that are the same. They're both b. What would that simplify to be then? X. Then if you do the same thing going the other way, you start with the f of x equation, and you surround it with the g of x equation, sorry.
No, you're okay.
Which means this becomes an exponent to that base. So it's b to the log base b. It's been exponentiated.
You know the joke that you made on the video about your roof yesterday?
It wasn't a joke. We actually did have a roof problem. That's why I had to go let people fix it.
Remember you were talking about it wasn't on fire and you weren't going to let it burn?
Yeah.
I was the only person who laughed and it made me sad.
Are these both bases? It's base to an exponent that has a base. Are these both the same letter? What do you think the answer is?
I bet it's X.
I bet you're right.
Is the x, so the exponent of log is on the same line?
This is the same line. It's log base b of x. It's so hard to write this without lines.
Again,
Yeah, it's so hard to do that. Well, yeah.
So anytime you get either one of those two, it's just x.
Yeah, whatever the exponent is, it drops. And this is what allows you to do something like this. You have the log base 3 of 9 to the x. If I want to simplify that, I'm going to try and rewrite 9 as a base 3. How do you rewrite 9 as a base 3? 3 squared. So this would equal the log base 3 of 3 to the 2x, because it's, that x stays up there. Do those have the same basis? What falls? The 2x. So this would simplify to equal 2x. Okay. JC, you look worried.
I don't think I'm worried yet.
Okay. Let's try this one.
Wait, are we gonna have to write those in like the same form that we wrote them in yesterday?
What do you mean?
Because then wouldn't it be, wait, I think I'm just confusing myself.
This would be something like simplify.
So it won't ever have to be an exponential form?
It might, if it has to go, if it says to rewrite from logarithm to exponential, you could go back and forth. But this property simplifies it out just to be 2 to 2x. Some of those rewriting back and forth, they don't simplify a lot of times.
So it'll just say like inverse?
It'll say find the inverse, it might say simplify, it might say something along those lines. Yes, sir?
How did they get the word logarithm?
Not a clue.
Okay.
They were sitting on a log and they figured it out. Sir?
It's probably an odd question, but what are we accomplishing really with these inverse log?
The inverse log, and I'll show you in a second, is because when you're solving equations, you have to use inverse operations, right? So you have to learn about how to do inverses with logs, so we can do equations with logs and stuff.
Yeah, but if the exponent just equals,
What'll happen is, and this is a great question, because what'll happen is when we get to stuff in, is it 8.6, I think? By learning about the different ways of working with logarithms and their properties, you'll be able to solve for x by working backwards and using inverse properties, okay? If I treat this log base 6 as just another thing, log base 6 of something, what do you think you would have to move first? Multiply everything by 2, good. So you have log base 6 of 16x equals 6. Now, to undo a logarithm, I'd have to do some inverse, get one of the properties, or figure out a way to get rid of the base. Well, how would I get rid of that base? Just like I was showing a second ago, anything I do log base b to b, the exponent would drop. Or if you take b to the log base b of x, since those two bases are the same, it would drop. So one of the ways to solve this problem is to raise everything to make these exponents. So it's 6 to the log base 6 of 16x and 6 to the 6th. So these would drop out, you get 16x equals 6 to the 6th power divided by 16, and there's x. You use these properties to do these problems later. That's all. It's a good question. Because a lot of times people are like, why do I need this? Well, 3 days ago. Yes, ma'am.
On the last page,
Yeah.
did it end up being 2x because the 3's cancel each other out?
Yep. In terms of, when you have whatever these bases are, if these bases are the same, whatever this exponent is, it just falls.
Okay, what is the balance?
Then it won't work.
So you just leave it like
And we'll worry about that when that happens.
that. Okay.
Yes, ma'am.
So if you go back to the old page, you had like, you added. No, the other one. The one you did, like, yeah. So you put like, you put a 6 to the, sub
Yeah.
each side.
Mhm.
Then why on the right side, like 16 equals x? Is it 6 like normal to the 6 up? Or
Yes, 6 to the
down?
6th power.
Why would you change that?
What I did here is this little thing called exponentiating. We'll talk about it when we get to it, okay? I was just showing you what's going to happen eventually. Okay?
Wait, so we don't,
Not today.
that's irrelevant.
Right.
Okay.
And that's irrelevant. So, you drew that too.
No, I didn't, Mariah did.
Who told Mariah did? I thought you did. That's why I thought it was great. Anyway, log base 2 is 64.
It was so funny.
Yeah, he like had to wait too.
Anyway, log base 2 is 64. I want to try to rewrite 64 as a base 2. Very good. You're right. So this is the same thing as saying log base 2 of 2 to the 6th. Again, you have the base 2 for the logarithm and base 2 for the exponent.
How did
Since
that,
those bases are the same, the exponent falls. What's that?
how did that happen?
How did what happen?
Oh, wait.
I just rewrote this as 2 to the 6th.
Okay, I got it.
So you're trying to
Sir.
get it.
Isn't this then what we sort of did yesterday?
A little bit.
Like x squared.
And these are the properties that make all that work. So what happens then is that you can simplify these. We just did the log base 3 of 9 to the x, but what's 10 to the log of 2?
10 to the log of 2.
10 to the log of 2. It's 2. Because what's the log base that you don't see? 10. This is the same as saying 10 to the log base 10 of 2. Are these bases the same?
Yes.
So the answer is 2. Remember, any logarithm, a logarithm without any base is called the common log, and the common log is 10. Okay, the common log is 10. Any other base is denoted by the subscript. Okay, any other base would be denoted by a subscript. What? What's wrong, Bella?
I don't understand why log all of a sudden became an exponent.
It can be anything. Thanks, and anything can be an exponent. 3 to the pi. Why not?
3 to the
But
pi.
I don't understand why. I don't understand how you transform it.
All I'm showing is property rules. I'm just showing property rules.
So you just pretend like log is x.
Sure, if you want, whatever. Whatever makes you think, all we're showing is property values, not values, but how things work via the use of the properties. What do you got?
What is a log?
Logarithm, again, remember we talked about this yesterday, or 2 days ago. Logarithm allows you to do this.
So is it like just a simplification of a number?
It's an exponent. A logarithm is an exponent. A logarithm allows you to find a value of an exponent that makes something like this true. Okay? What happens in order to solve for this, in order to solve for x when it's an exponent, you'd have to take a logarithm. Because the property that allows you to get this value of x to fall is, well, I gotta take the log base 2 on both sides. Because log base 2 of 2 simplifies out to 1, which allows the exponent to fall, and you get x equals the log base 2 of 6. That's some decimal. The logarithm allows you to account for the decimal values. That's all it is. Okay? Sir?
I remember on the first day of school, you showed us that. You told us that.
You're fine. Remembering stuff.
It was really good.
What did he say?
Oh yeah, speaking of things behind it on, Anna, will you grab the change thingy? We're doing the change thing for $12, so if you have any spare change, please help out the shelter box.
I got you. I got you.
You guys are awesome.
Do we get?
I literally have a
No,
piggy bank
you don't
full
get
of
extra
those.
credits.
Oh yeah, I really.
We could win food. How's that? All right, let's try these 3 real quick.
Okay, wait, hold on. Is this spare change, right? Like, just change? Oh, I got this. I'm bringing this. I have like $4 change.
Anyway, we want to use the properties of logarithms to simplify these things out. It's still money.
How are you gonna get it?
Guys, come on. You don't have much time before people start bailing out in here for bandit stuff. Log base 25 of 5. In order for us to simplify this out, we need to rewrite 5 as a base 25 with some exponent. So you have log base 25, and I need to make this a 25 to some exponent. So what would it have to be? Careful. If I want to take, I want to turn this into a 25, so the 5, if you guys are going and say, oh, it's got to be 25, that won't turn this into a 25, but what would? Hold on. We want to make this a base 25 Oh, did I? I did that. I did that third hour too. It should be. I'm sorry. I did the same thing third hour when I got caught in the 5s and the 25s. It is 25 to the 1/2 is the same thing as 5. Okay? Sorry. I did the exact same thing in third hour, and I thought I would remember not to screw up. Wrong.
I don't understand all the fractions. I don't get it.
What's 1/2 power mean? Square root.
Oh!
So this equals.
Oh, I get it now.
Okay. Take a look at the next one. Log base 6 of 1. 6 to the 0. Very good. So your answer is 0. You'll see more of those. Because remember, anything, if it's a log base whatever of 1, one of the rules that we had was log base b of 1 is always 0, because that means that base to the 0 power is going to give you 1. No matter what that base is, if it's base whatever of 1, the answer will always be 0. Okay. Same deal when you have log base b of b, that will always equal 1. So if it's log base 6 of 6, that means 6 to the first power is 6. And lastly, I have 10 to the log of 4. 4. What's wrong with you?
Oh, yeah.
Because it's common log. So let's talk about the not so common log.
Do we have to?
The common log, like we said earlier, is called the log base 10, it's just written as log. The not so common log is called the natural log. The natural log is log with a base e. LN stands for natural log.
Why is that an L?
Because log natural.
Log natural.
I think that was the original way of saying it, yes.
Natural.
Sounds next to the natural log button. Good question. Again, on these calculators here, guys, the log button here, if you press it, one next to 7, is just common log. It's base 10. In order to get the base to change, you have to hit alpha window 5. Alpha window 5 allows you to change your base. Natural log is log base e. And it's important to that because we'll be able to undo things via e and natural log. Okay? If I'm not mistaken, you see natural log stuff again in like chemistry and biology stuff. It's not more of the science stuff because of the way that curves fit in bacteria growth and all that stuff. Okay? So here's what we do with these. Sorry. What these are going to allow us to do, and I forgot to add this. We're going to be able to find their inverses rather easily. So let's do this. Let's do the inverse of a natural log problem. Now, if I want to find an inverse, when we did this before, all we did was flip-flop x and y and resolve. Remember that?
Yeah.
Okay. You do the exact same thing with with natural logarithms. Okay. Sorry. We do the exact same thing. So flip-flop x and y. We're going to get x equals the natural log of. So now I have to figure out a way of undoing natural log. Another way to write natural log is log base e. Remember, log base e and natural log mean the same thing. Going to properties then, what can I do to get this y plus 1 alone? Ah. So what goes to the e power? Close.
Everything.
You exponentiate. You put this e to the log base e.
Yeah, that's what I meant.
which means this side is e to the x then. See what I'm doing there? I'm creating that logarithm to be an exponent now. So now I have a logarithm with a base e that has a base of e. Sounds a lot weirder than it is. Are these two the same? So what happens to the y plus 1? It drops down. So you get e to the x is y plus 1. Therefore, e to the x minus 1 is y.
Yay, man.
Is it great?
I have my joke.
No.
That's not wrong.
What?
That's the wrong
What are you doing?
That's the frosted
Winnie the Pooh?
You missed my irrelevant joke. It was awesome.
It was really funny.
Yeah, we can probably look at it because.
Sorry, I was just messing with you. All right, let's try another one.
Is this just like stuff we have today? Hey.
Watch your mouths. Flip flop x and y.
Watch your mouth.
Find the inverse of natural log.
Did you collect our ones you just love?
No, we're adding to it.
Oh, watch your mouth already. How exciting.
So you flip flop your x and y.
He was watching his mouth while making the peace sign. You should well.
You should write him up.
It's more than.
Can I just feel bad for him? Is it as about everybody else? Let's look at him with shame. There you go. How do you undo a natural log? You e it. Do you have to rewrite it as log base e if you don't want?
No.
You can if you want. You just if you e it. Just eat it. Just eat it.
So you have nothing, you don't have, you're done?
Done.
That's it?
Yeah.
Math is
So many
exciting.
exponents, or so many letters.
Wait, so L times N is D.
We're not L times N. It's it stands for natural log.
Oh.
Ln is natural log. Natural log is log base e. So if you want, you could have rewritten this as x equals log base e. What I'm doing here is changing that. And it works. Now I got that stuck in my head. D, 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 D.
Homework?
I want to do another inverse real quick. Real fast. Let's do the inverse of this. Remembering that, well, this is real tough to remember. There's your inverse. Those are inverses of one another. If you substitute in one for the other, you're still going to get x. You can if you want. Because what
necessary?
No. It's one way to make sure you did it right. And when you have logarithms, to do the inverse of a logarithm, it's really fast. It's the base to your value. And it works. Because if you go back and forth with it, if I start with 9 to the x and I surround it with a log base 9, what do you get? And if I go with 9, if if I start with the log base 9, and of x, and I surround it with the 9, what do you get? Okay. What I want you to do tonight are go here Monday morning.
Monday is flex.
Monday flex. Oh, there's no flex on Monday, so
Monday,
there.
right.
So they have another assembly on Monday.
What?
I'd like you to go 48 through 64.
What page?
What page?
Same page as it was before, 490. 48 to 64. A lot of these you will fly right through.
Oh, boy, I got it.
Maybe I'll float.
You might float, you might meander.